Good morning. We are team to be or not to be, and this is our Sprint 1 progress update for BudgetBites. BudgetBites is a meal planning application for college students. It helps users find meals based on their budget, dietary preferences, and restriction. First, let's have a brief introduction. And Qiyu, the product manager. Michael is the Scrum Master, and Kazia and Evan works as the development team member. Today, we will give a project update, review the technical progress and testing, demonstrate several functionalities, explain our Sprint 1 accomplishment, and review our Sprint 2 backlog. First, the database. The database is the main data foundation of BudgetBites. It currently contains 90 recipes and 442 normalized ingredients. The recipe data comes from Wikibooks and focuses on beginner-friendly meals. Each ingredient has a normalized name, default unit, and category. The database also contains 15 allergen types, and we also created 26 dietary tags. The database has a rebuildable data pipeline. The process starts with a versioned CSV state files containing ground data and their relationships. A database importer validates the files and imports them into SQLite. The database uses foreign keys, unique keys, and status checks to maintain data consistency. This allows meal planning, filtering, and grocery list features to use the same data sources in the future. And this is our database relationship design. The recipe ingredients table connects recipes and ingredients because one recipe can contain many ingredients, and one ingredient can appear in many recipes. The ingredients allergens table and the ingredient dietary tax table connects ingredients with allergens and dietary tax. This design avoids repeated data and makes updates easier. And the screenshots show the data stored in SQLite. Recipe records include titles, servings, preparation time, and cooking time. Ingredients records include names, defaulted units, and categories such as dairy, protein, and spice. And we can see the allergen and dietary type tables store the supported restriction categories. This is an example of query. This query retrieves the ingredients for chicken curry. You can see that we need these ingredients to make chicken curry. The result includes ingredient names, quantities, and units. This information can later support recipe details and grocery list generation. And this is another example. This query checks chicken curry for allergen and dietary conflicts. Because the recipe contains milk and chicken, it identifies milk as an allergen and reports conflicts with vegan, vegetarian, dairy-free, and lactose-free tags. This database structure will allow BudgetBites to filter meals based on user restrictions.
For Sprint 1, the interfood allergies progress, my main feature was allowing users to enter their food allergies. The user story focused on helping users avoid unsafe meals during meal planning. I implemented the allergy input feature, allowed the users to enter and save multiple allergies, and added a way to display the saved allergy information. I also made a feature so it can later connect to the meal planning system. By the end of the sprint, the allergy preference functionality was completed and prepared for future integration. To test the feature, I created several manual test scenarios. These included entering one allergy, entering multiple allergies, submitting no allergies, updating the allergy list, and checking the meal exclusion. The test helped to confirm that the system correctly stored the information and handled both the positive and negative input scenarios. The meal exclusion test is intended to verify that recipes containing the restricted ingredients will be eventually removed from the meal generation. So the top images for the allergy functionality demonstration shows the updated account menu with the enter in viewing of the food allergies. The picture in the bottom left shows the functionality after selecting the enter food allergy option, and the program asks how many allergies the user wants to enter. And in this example, peanuts was inputted, and it confirms that it was accepted and stored successfully. In the bottom right, view food allergies was selected, and the program displays the saved allergy list, showing that the allergy entered in the previous step was stored correctly and can be retrieved later.
For Sprint 2, I was responsible for developing the grocery list and the pricing features. The goal of this feature was to take the meals selected by the user and turn them into a grocery list while also making sure that the total cost stays within the user's weekly budget. So to do that, I developed a grocery list module to manage every grocery items generated from the meal plans. One feature I added was the ability to automatically combine and duplicate ingredients into a single shopping list. So for example, if two different meals both require chicken and rice, the application combines those into one grocery item instead of the listing them twice. I also implemented a grocery cost calculations using the ingredient price and added budget validation so the application can compare the estimated grocery total against the user's weekly budget. If the total exceeds the budget, that information can be used later by the meal planner to recommend different meal options. So even though the entire application isn't finished yet, this feature provides the foundation for generating grocery lists and helping the user stay within their budget. So once the grocery list module was implemented, I focused on making sure that it worked correctly before getting integrated with the rest of the application. So I created several test scenarios that covered the main functionality of the module. Some of those tests included adding grocery items, removing grocery items, combining duplicate ingredients into a single entry, or calculating the grocery costs and checking whether the grocery total stays within the user's weekly budget. I wanted to test both the normal use cases and the situation cases where the budget would be exceeded to make sure that the module behaved correctly in different scenarios. So after running those tests, I confirmed that the grocery list functions were performing as expected. The grocery totals were calculated correctly, and the duplicate ingredients were merged properly. And the budget validation also worked as intended. So completing this test gave us the confidence that the module is it's stable and ready to be connected with the meal planner and the rest of the project. I want to show a quick demonstration to show how the grocery list feature is it's already working behind the scenes. At the top of the slide are the automated tests for the grocery modules. These tests verify the core functionality I talked about on the previous slide, including adding grocery items and combining duplicate ingredients. Running these tests help confirm that the module is it's functioning correctly. At the bottom is an example of the program running. You can see that the grocery list was generated. And for each item, it also shows each item's groceries cost and the user's weekly budget. So in this example, the total is under the budget. So the application lets us know that the grocery list is within the spending limit.
So here you've got our foundation. Sign in is done. Registration, login, and log out are all merged and working end to end. So users can already create an account and get info or get into the app. Right behind that, input validation and security is in final review. It sanitizes and validates everything coming through our forms, budget, allergies, preferences, before it ever touches the database, and it protects the sign up and profile forms specifically. And the user profile itself is our biggest area of active work right now. 25 points across 7 stories. Things like entering your weekly budget, dietary preferences, allergies, cooking equipment, and available ingredients. Most of those are moving through review or in progress as we speak. Sprint 1 backlog accomplishments. Zooming out to all of our Sprint 1, we committed to 34 points. Account registration, login, and logout are fully shipped. Dietary preferences, food allergies, and that input validation, and security story are built and sitting in final review. Our recipe database, the 50 plus recipe target, is actively being populated. All told, 21 of our 34 points, about 62%, are done or in final review, with the rest close behind. This is our software test. You can see that we've got 47 out of 49 tests passing. The grocery list, logic, count and security, budget and review. The testing is going quite well. We haven't run into any big problems as of now that can't be addressed within a couple hours. So things are going smoothly. This is our Sprint 2 backlog and our planning poker estimations. We took a bunch of votes, and for Sprint 2, we ran planning poker on all 16 stories. Everyone votes privacy like you should. We reveal together and then discuss whenever there's a spread, which happened on every story in round one. That's normal for a first pass, though. 7 stories had a small enough spread to settle right away. For 8 more, the discussion actually surfaced real scope differences. For example, whether the account system was already assumed built or whether the grocery pricing needs to be separate, integration per store. And that conversation gave us a defensible number, which we are making as proposed, pending confirmation about our next stand up. One story, implement user interface, still had a 13 to 21 spread even after discussion. Rather than force a number on it, we're flagging it to split it into smaller stories. Altogether, that's 113 points across 16 stories for Sprint 2. This is our Kanban board. Here's a live GitHub project board, 10 stories to do, are in to do, including 3 new data later stories we just added, the user profile database and the meal plan database, and updating the recipe database for cooking equipment. 15 stories are in progress. The team's actually already pulling ahead into Sprint 2 and 3 work while Sprint 1 wraps up. 4 are in review and 2 are fully done. Account registration and log in and log out. Nothing stuck. This board reflects exactly where GitHub says we are today. As you can see, we've got our program up and running. You can choose an option. Now I've already created a profile, a sign in. So what you do is just choose an option. So I want to sign in, username. Then it'll ask you for your password, which needs to be 8 digits at least, with a capital letter, a lowercase letter, and a special character. So now that I'm signed in, I can actually upload a profile image, view a profile image, enter a food allergy. So I'd say, let's do that. How many allergies would you like to enter? Let's just say we'll enter 1. Enter allergy 1, which will be peanuts. It's a common enough allergy. I can spell. And you can see the food allergy is saved. If you want to view the food allergy, we'll just press 6. And you can see food allergies right there is peanuts. The sign-in is very secure. Our security, our user profile is very secure. Uploading a profile image, I feel, is going to be rewarding for the user as an experience. I have not uploaded an image yet, but we can definitely do that in another demonstration. But just to show you that things are up and running and it's looking good.
Okay, so this is our Sprint 1 presentation. Thank you for watching, and we look forward to Sprint 2, and we'll finish all the functionalities we mentioned before in Sprint 2, and I hope this application will going to be a full package. Thank you.